personally, I don't know, like, I'll usually,
I'll give you another one of these.
I don't have a copy.
Oh, that's the one we did,
I redo it.
So we all had different MAC addresses. I'm going to use this one today, and we'll use my MAC addresses today. And instead of me writing down all the MAC addresses, I just wrote down the last 4 digits of the MAC addresses. Yeah. Yeah, this is a new one. This is a new one with Mark's MAC address.
really?
She's so lucky it was there. Son of Facebook. That's like
Yes. We're going to work on this. So these are my MAC addresses. I just wrote down the last 4 digits of the MAC addresses so that don't have so much stuff on the page. So what we have to do is we have to identify the source IP, destination IP, and the source MAC and the destination MAC. That's it. So this I'll call SIP, DIP, SMAC, and DMAC. Just for short forms, because, yeah. So, what we have to be able to do is, as the packet leaves this guy and goes out onto the network, it has all 4 of those addresses. And we have to be able to identify source IP, destination IP, source MAC, and destination MAC. So, he's pinging the bottom right server, right? 192.168.99.254. So, where the video made a little bit of a boo-boo is that it kind of implied that the router automatically picks up the packet. It doesn't automatically pick up the packet. It has to, my PC has to put in the MAC address of my router in order for it to get to my router, right? The switch has to deliver this frame to the router. And there's no magic going on. We got to use the destination MAC of my router in order for it to get there. So the source IP and destination IP are hopefully obvious to you. The source IP is me. Source IP is, make it a little smaller. The source IP is my computer, right? Source IP is where it's coming from. 192.168.10.10. So I drew the picture of the guy. he's on 10.10, and he's pinging the bottom right server, which is 192.168.99.254. So the source IP is me. The destination IP is the server, right? 99.254. We're good so far, right? Not a problem. The PC says ping 192.168.99.254. Well, the packet goes out, and the source IP and destination IP is coming from me, 10.10. It's going to the server, 99.254. That's the IP layer, the network layer packet. Okay, it's Ethernet, so it goes into an Ethernet frame. And gets labeled with a source MAC and destination MAC. Well, the source MAC is me. So my MAC is 9497. That's me. Right? We're not writing the whole,
Just use the last four numbers.
just the last four numbers. For sanity.
Okay.
Just for sanity purposes. Because we can't write a 12-digit number. It just takes too long. As hexadecimal, it's really hard to work with. So. Right? So that's where it's coming from. And in the Ethernet, the data link, this layer, the frame destination MAC is the router. DD01. There's no magic. It's got to be DD01 for the switch to deliver it to the router, right? It's got to have, it's a unicast frame. It's got my MAC as the source, the router as the destination. So it goes to the router picks it up, decapsulates it, looks and says, okay, I got an IP here, 192.168.99.254. Do I know where that network is? Yeah. It's the other side. It's the interface on the other side, because you guys set that IP address up, right? You put that into the router. The router knows about the 99 subnet. So it says, yeah, it's over on the right-hand side. Okay, so I got to re-encapsulate it now into a new Ethernet frame and put on the correct MAC addresses. So over here, now we're over here. So I'm going to draw this arrow. I'll use my crayon here. So we're over here now. I guess, yeah, I'll draw it up here. We're talking about right here. And now we've got a new source IP, destination IP, source MAC, destination MAC. Well, the IPs don't change. The source IP is still the same. Children. 192.168.10.10. It's still coming from me. The destination IP doesn't change. 192.168.99.254. But now it's coming from the router. The MAC address is the source MAC is DD02. And the destination MAC is 6C52. So when the router sends it out the other Ethernet interface, right, takes the IP, doesn't change it, doesn't mangle this thing at all, but it does create a new Ethernet frame with a new source MAC and destination MAC. Because the switch knows DD02 is there, and it knows 6C52 is down there. So we're good. Okay? So the MAC address is changed as it goes from router to router, from hop to hop. Not the switch. The switch doesn't change anything. The switch just forwards it to the proper destination MAC address. Okay, server receives this thing and looks inside and says, oh, it's ICMP and it's coming from 192.168.99.254 and it's destined for me. So, okay, so he takes that and looks inside and he says, oh, it's ICMP echo request. Okay, it's an ICMP echo request. Well, what should I do? I guess I'll do an echo reply. So he turns around and creates an ICMP echo reply. That's this white thing inside. And addresses it accordingly. So it sets up now the source IP becomes the destination IP, and the destination IP becomes the source IP. Because we're turning things around now, and we're going to go this way. Now, what's our source IP, destination IP, source MAC, and destination MAC? Well, our source IP is the server. Yeah,
Are you wanting us to write down yours or our own?
Mine.
Yours?
Yeah.
Okay.
that's why I gave you a new blank sheet. Did you get it? A new blank sheet? Okay, good. Yeah, use mine. Okay, so the source IP is the server, 192.168.99.254. And the destination IP is me, the guy in the top left there, 192.168.10.10. And it's coming from the server, which is 6C52 MAC address. And where's it going to? Anybody want to guess what the destination MAC address is? Well, we want the switch to deliver it to the right destination, right? DD02. DD02. So let's number these steps. So I'll put a number here and just say this is step 1, big 72. Step 1. This is 2. Maybe make it a little bit smaller. 2. This is 3.
So this next step go to directly to the PC or to go
Yep.
to the server.
Goes to the PC now. So the router has it, right? The router picks it up. So it's going to the right side of the router. The router picks it up, says, yeah, that's my MAC address, DD02. So he looks inside and says, okay, where's it going to? Well, it's going to 192.168.10.10. He says, do I know where 192.168.10.10 is? Yeah, I do. It's my left-hand side. Because I got an IP address there called 10.1, right? So he knows subnet 10's on the left. So he says, okay, I'll deliver it. So he puts it back into the Ethernet frame and writes the new MAC addresses on it. And the source MAC, destination MAC over here. So this is like step 4. And I'll write the addresses down a little smaller. So source IP, destination IP, source MAC, destination MAC. Well, it's coming from the server, 192.168.99.254. It's going to me, 192.168.10.10. It's coming from, oh yeah. So this is the router now working on the left-hand side, encapsulating this IP packet into an Ethernet frame, what's the source MAC and the destination MAC so that it delivered to the PC up there? Well, DD01 is the source, and 9497 is the destination MAC, and it gets delivered to me. So, with Packet Tracer, on Thursday and Friday, you will be doing this. Let me, oops. So I'll be giving you this Packet Tracer activity. And we will be simulating, so we'll be switching to simulation mode, and we're going to want to see ICMP. There it is, ICMP. So we can specify what packets we want to see. So I'm going to say I want to see the ICMP packets, because that's what ping is. Ping is ICMP. Okay, I'm going to maximize this. So up here, I'm going to ping 192.168.99.254. And there's the packet. Sitting there all nice. I can look inside of it by I'll go capture forward once, and it makes it to the switch, and that's a good place to look at it, because it's coming from the PC and going to the router, and I can look at the inbound coming into the switch and outbound going out of the switch. Shouldn't make any difference because the switch doesn't mangle it at all. It doesn't change it. The switch just forwards it, right? So if I look at the Ethernet frame, I can see the source MAC and the destination MAC. I can see in the IP part inside here the source IP and the destination IP. There's other stuff in there too, but we're not going to study that yet. We're focusing on addressing for now. So what you will be doing is snipping these and pasting them into a Word document, highlighting the addressing at each of the 4 locations. The left subnet going to the right subnet going to the right subnet going to the left, and the left subnet going to the left. So, okay, so if I let this guy forward through, and this is kind of cool, because remember the first time you pinged across the router, the packet got dropped? Watch what happens. Gets thrown away. And we got to get the second one. So we get the first one is dropped. See, it says request timed out. Remember that? So don't worry about it. The next one goes through. And so now it's in the router. And the router is now, I could look at the inbound and the outbound if I want here. The inbound would be on the left side of the router and the outbound would be on the right side of the router, but that's a little confusing. So let me just let it go one more step until it hits the switch. And I'll look at it at the switch, because then the inbound and outbound don't have any differences. So it doesn't matter if I look at the inbound or the outbound, they are the same at the switch. Where the router, the inbound is still the left-hand side, the outbound is the right-hand side, so you could confuse yourself if you clicked on the wrong inbound or outbound. Okay, so so we're looking at the thing now, and look at the source MAC DD02 and the destination MAC 65C2. And the source IP hasn't changed, 10.10 going to 99.254. And we capture forward one more time, hits the server. Let's look at the inbound and outbound. So the inbound will be the source IP is 10.10, destination is 99.254, but the outbound is going to be different. The outbound is source IP 99.254, destination IP is 10.10. Okay? So I could, I could let it hit the switch and I'll look at it there. And then the inbound and outbound doesn't make any difference. And you can see the source MAC is the server, 6C52, the destination MAC is DD02. And the source IP is the server, destination IP is me. Okay. That's what you're going to be doing on Thursday and Friday. Now, that's ICMP. I still got 10 minutes. I want to give you a full hour to work on what you need to work on. The last thing in here today is ARP request. Very interesting protocol. ARP, Address Resolution Protocol. Well, it's not complicated really. It's pretty easy. So ARP, the Address Resolution Protocol, is used to learn the MAC address. We didn't tell the computer what the MAC address of the router was. We didn't tell the router what the MAC address of the server was. They have to learn that. And it uses ARP to learn it. So, our IP addresses are chosen by the local system administrator to suit the local network. Ethernet addresses, oh my god, I'm losing my voice, are burned in to the interface hardware by the manufacturer, right? First three numbers of the MAC address identifies the manufacturer of the equipment. So Cisco versus TP-Link or Linksys, all those manufacturers of networking stuff, they all have their own first half of the MAC address. Okay. Computers need MAC addresses, right? When the computer encapsulates the IP into the Ethernet, it's got to be able to write the destination MAC address on that Ethernet frame, or it ain't going to get there. So the computer has to learn the MAC address. Well, I've shown you my ARP cache here, and my computer has pretty well learned all your MAC addresses. They also, so the reason the first half of the MAC addresses look identical is because you're all Dell computers, except for those of you that have a laptop. Oh, but if you're on the Wi-Fi network, that would be a completely different subnet, right? Wi-Fi is separate subnet. It's got a router between us, right? Wi-Fi. The Cougars is a separate subnet. Different broadcast domain. Different IP addresses. So that's kind of cool. All Dell computers. And these are your unique identifiers over here. So it's ARP that's used to learn that. So translation between IP address and MAC address is the Address Resolution Protocol. IPv6 uses something different, but we're not there yet. We're just working with IPv4. So the way it works, let's get down to where it works. ARP request. Come on. Oh, here we go. This is it. This is the way ARP works. It's pretty simple. It just sends out an Ethernet broadcast. So the PC, first thing it does before it sends out that ICMP packet is it's got to learn the MAC address of the router. So it sends out an Ethernet broadcast. It says, hey, right? The computer decides he's gotta send this to the router, the gateway, right? 192.168.10.1. So he says, hey, anybody out there got the MAC address 192.168.10.1? Because that's my gateway and I gotta send this Ethernet frame to it. And the router responds and says, yeah, I'm 192.168.10.1 and here's my MAC address. Good, so now the PC can send this thing off, as we saw, to the router interface. And he'll pick it up. So, that's ARP. Now, to show you that in Packet Tracer is a little bit difficult. Because, unfortunately, the PC, if I go ARP here, ARP-A, and I look at my ARP cache, I don't know if you can see that, 192.168.10.1, I already know that address, so it ain't gonna send an ARP request out. So to be able to see that, I have to, I gotta restart my lab here. So let me just reload this. No, I don't want to save. I gotta load it in again. Okay. I guess I could have powered off the PC and powered it back up again. I should have tried that. Right, you can actually power the PC down by pushing that button. See, it goes red? Because the PC power is turned off. Put it back on. Yeah, I could have just done that. I should have. That would have been a good example. Anyway, if I look at my PC ARP cache now, you'll see it's empty. So this is good. So now I can demonstrate the ARP request and reply. So I'm going to go into simulation mode, and I'm going to say, I want to see ARP. Oh, it's already set up. So I want to see the ARP request. So instead of ICMP, I'm looking at ARP. I can look at both. I'm looking at ARP and ICMP, so that's through edit filters. So that you, because there's all different stuff goes on, you don't want to see all that stuff. Okay, so ARP and ICMP. Let's have a look. So I will ping 192.168.99.254. Well, my PC says, oh, is that on the same subnet as me? If it is, I can ARP for the destination directly. But no, it says 192.168.99, that's a different subnet. I gotta go through my gateway. Remember, one of the things you had to do last week was, until you set up your gateways, you couldn't get out of your network. Once you set up your gateway addresses, then you can get out of your network, and here's why. So, that green packet there is my ARP request, and you will see the source MAC is me. What's the destination MAC? You see it? FF. So watch what the switch does with it. Watch this. You ready? Here we go. Out all the ports. Broadcast everybody. These guys throw it away. They have a red X. This guy picks it up, and he will send the ARP reply back. And there it goes. This is the ARP reply coming back from the router saying, it's coming from DD01, and it's going to 9497. That's me. And it's saying, I'm 192.168.10.1, and here's my MAC address. So once it gets back to the PC, if I cancel this, and I go ARP-A, you will see now I have the router's MAC address in my ARP cache. So as long as I leave the power on, I think the ARP cache lasts for 30 minutes or so, and then it disappears. The idea is that you don't want to do these broadcasts all the time. Every time you want to send a packet out, you don't want to broadcast. So you learn the MAC address and then you keep it in cache. Now, the problem is if you change gateways, you buy a new router and put a new router and it's got a different MAC address, your PC's trying to talk to the old one. So it ain't going to work until that cache clears out. ARP again for the new gateway, so. Okay, so that's ARP. Very important, basic technology in networking. Really important you understand it, because if you're trying to solve a problem with a network, you have to understand what's going on in the background. That's why I call this course, this is learning network plumbing, how it works. Dan's class was learning network applications like servers and sharing folders and printers. That's fine, but this is the underlying plumbing of how a network works. Okay, so that's what we're going to be doing on Thursday and Friday, is doing packet tracer and capturing packets and snipping and pasting into Word documents and hopefully understanding. Any questions? All right, I will leave you with an hour to finish up your hardware labs or whatever it is you got to finish up, and have fun. Oh, I wanted to mention, to get rid of the yellow blobs on your device manager, you go to Dell and download the drivers that, first of all, I hope you experienced that horrible utility that Dell provides. It's horrible. I'm sorry, I apologize. I apologize for putting you through that, but hey, that's how we learn. Yeah, don't use that tool. It's pretty well useless. You have to put in the what is it? GX 780.
It should just be 780.
Yeah, Optiplex 780. Yeah. There we go. Drivers and downloads. We got Windows 7 32-bit. And if you get the ones that say chipset, there they are. They are the drivers for the chips on the motherboard, and they are the ones that are the yellow blobs. So if you download those 4 drivers that say chipset and install those, you will get rid of your yellow blobs in your device manager.